Yes. Now we welcome Matthias from TI&M, and you will be talking about your experience with OpenAI, right? Thank you. Thank you very much. Just give me 1 second. Need to have the little cheat here as well. Good. All right. Hi, everyone. So we've been employing open source LLMs for the last couple of months, and I'd like to share some of the lessons learned with you today. So let's start with a quick poll to understand the audience's experience. So first, who of you has already worked with LLMs? Good. Then next, who has experience with open source LLMs already? And has anybody already fine-tuned or, sorry, there we go, fine-tuned or augmented an open source LLM? Great, interesting. We already have some experts in the field. Great, so I'd like to start by looking at this chart from Gartner to show where we're actually at in terms of the hype cycle for generative AI. As you can see, large language models up here have already peaked in terms of inflated expectations when compared to open source LLMs, which have actually came to this picture rather recently. Despite this gap, both are expected to reach the productivity plateau over here in around 2 to 5 years, which means that actually we are moving really, really fast in the open source space. And yeah, it's really an interesting time right now to work with it. Also, there is much more interesting stuff going on here, and we will touch on some of these terms and topics in the next 10 minutes. So, what are really the main arguments for using an open source large language model? Well, the main reasons are usually due to data privacy, the need to customize a language model to your requirements and needs, or just to your liking. Then reduced latency and also cost effectiveness. In the next slides, we will look at an applied use case in the financial industry where we developed a multilingual chatbot specifically for confidential data. So one of the first things that you actually need to do is to choose one open source language model from the big list of language models. They actually appear almost on a daily basis right now from many different bigger companies. And there are a lot of benchmarks out there, many of which are actually already corrupted by now, meaning that simply looking at these corrupt benchmarks do not really reflect the actual performance of a language model on a task. That being said, there is the LMC's chatbot arena that was introduced to actually mitigate this problem. It is a platform where humans can look at outputs, or rather compare different outputs of LLMs without knowing from which LLM it actually comes, and then they can manually rate the responses to their question. This one is actually currently probably one of the most trustworthy benchmarks out there. Then Mixeval focuses on real-world user queries, and it achieves roughly a 96% correlation to the LMC's chatbot arena, with the big advantage that you can actually evaluate an open source LLM automatically. Then EFEval is usually or can be used to check the model's ability to follow detailed instructions. And Arena Hard is recommended to use if you're interested in a model's ability for multi-turn conversations. But in the end, though, it is most important that you really evaluate the model on your downstream task to see how it performs. So, how can we actually adopt a model to a specific task? Well, there are usually, there are really two main high-level approaches. First one is in-context learning, the other one supervised fine-tuning, both of which come at their advantages and disadvantages. So in-context learning usually is great to do if you have no chat conversation data. It also has the benefit that it is able to mitigate some of the hallucination problems that we currently face with language models. However, it comes at slower inference mostly due to the longer context, and also optimizing the retrieval part can be rather hard. On the other side, supervised fine-tuning allows you to align a language model to a company-specific style, and on the flip side, though, it really needs chat conversational data to be efficiently fine-tuned. Also, more experience is usually required to really pick the correct type of parameters. So, retrieval augmented generation is one specific type of in-context learning that we just heard of, and it encompasses the following elements. So that's really the high-level architecture of our use case. So in the middle, we usually have some sort of backend, typically Python in our sector of software engineering, and it typically uses LangChain currently. It is then connected to some sort of vector database, in our case Elasticsearch, also connected to a language model runtime, in this case Ollama, and also you need some sort of front end, can be web, can be mobile, that allows the user to interact with the system. Now, in our case, we also used weights and biases for experiment tracking and hyperparameter optimization, and in this specific use case, we've been using our self-hosted one, which is actually fairly simple to set up and possible with weights and biases if you find it, and yeah, allows you to really work with private data. Now, at the core of such an application, there is the LLM runtime. And we initially worked with Llama CPP on the left, but then swapped to Ollama very quickly. And we actually highly recommend working with Ollama. If you've never heard of it, go check it out on GitHub. It is open source, it's super easy to set up. It does a lot of stuff for you that you can get wrong very quickly. That is, for example, prompt formatting. If you ever work with the hustle of all the different open source models and their different prompt formatting, that's really great help. Also, it has a great API that streamlines development, the parallel development in a team. Also, it is actually built on Llama CPP, meaning that you can get all the Llama CPP features anyway once they are adopted. And quick side note here, if you use one of those, you can activate flash attention if you have a new enough GPU, and you can get 1.5 to 2 times the throughput just by opting in one flag. Now, to evaluate our ROG application, we used these 3 metrics. So, on the left, we have a quality score that assesses how well the generated answer actually aligns with the ground truth answer. A language score that just simply checks whether the answer whether the model actually answers in the correct language. And finally, the retrieval hit rate, in our case, to check if the correct documents are actually found by our system. Now, as you can see here on the left side, in our case, we pretty much checked or evaluated all the latest models. In this case, the Gwen 2 model, which was just recently released by the researcher colleagues at Alibaba, performed best, but all the, let's say, currently best ones, which is Llama 3 from Meta, Mistral, are right up there in the same region. One interesting thing we found here, you see the red one on the left, the Llama 3 8 billion model, so 8 billion parameters actually performed better than its bigger brother with almost 10 times the size. So yeah, it's really worth doing evaluation, because this smaller model obviously has much lower latency, which leads to much better user experience in the end, and also is much more cost effective. And another thing we saw is that the smaller models, though, they have issues when it comes to replying in the correct language. I mean, it's not really issues, but in roughly 8% of times, you can see it here, they are not responding in the correct language. So if that's a hard requirement, you probably need to go to a bigger one. Right now, could be changing in a few weeks already. Now, so the evaluation of the quality score is actually done automatically by another LLM. That's what we call LLM as a judge. And it has been shown that LLMs have a positive bias towards their own answers. So to mitigate this problem, researchers from Cohere recently published a paper where they propose using a panel of evaluators. So this essentially means that you replace one single big large language model with a number of smaller ones. You can see our choice here on the right side. So we went for basically the 5 best small ones. So we implemented this approach, and we found that it roughly reduces the cost by 4 times compared to GPT-4, and also it allowed us to do the whole or to run the whole evaluation pipeline fully on premise. Yes, and last negative point here is that it could increase the duration of evaluation a little bit, depends a bit on how you implement it. Yes, and that's already it. Thanks a lot for your attention.